Okay, welcome to 12.6 where we'll be doing combinations. So sometimes order doesn't matter, and that's going to be key as we talk about what's the difference between permutation and combinations. With combinations, order does not matter. So for example, let's say the coach thinks that all five players have the same talent. He doesn't care what order that he puts the girls in. He just needs to fill those three spots. Um, in that case, this is the formula that you have here. And notice this time I'm going to say the probability of the combination of in, choose, are equals this formula. And it should look fairly familiar. On the bottom, the only thing that changed is that I added the r factorial. And again, n is going to be the total number and r is going to be the number we're choosing. So here's an example. Manager asks to make a display using 5 different styles of shirts from 8 available styles. And how many ways can we choose the shirts? So again, I'm going to start on the top with how many shirts are there total? And there are 8. So that's going to be an 8 factorial. And then on the bottom, I'm going to start with, oops, didn't mean to do that, parentheses, how many I have total, 8, minus, how many are we choosing? 5, make that a factorial. And then the r, again, is how many we're choosing, so 5 factorial. And then again, like we did last time, if I were you, I would start by simplifying the bottom. So I know that that is going to be 3 factorial 5 factorial, because 8 minus 5 is 3. And then I'm going to plug in 3 factorial 5 factorial into my calculator. And so what I'm typing is, sorry, I didn't have it pulled up, 3 times 2 times 1. And without hitting enter, I'm just going to go straight into 5 times 5 times 4 times 3 times 2 times 1. So my phone has 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. Whew. And when I push enter, I'm getting the number 720. And now I'm going to work it like I did last time, where I'm going to type in 8 factorial. 8 times 7, 6, 5, 4, 3, 2, 1. And when I hit enter, I get 40,320. I'm just going to immediately hit the divide button and divide by 720. And the answer is 56. So, and that's all you do for these ones. Now it's important to know the difference between permutations and combinations. And again, the main key is that with permutations, order matters. Whereas with combinations, order does not matter. So they're going to give you some examples and you need to decide, does order matter in this case? So a playlist of songs on a digital media player is being played so that the songs do not repeat. In how many ways can the songs be played? With the way that this is asking in how many ways, to me that says they are asking about order. So that one would be a permutation. And unfortunately that's a photo so I can't type there, but the answer to the first one is permutation. Okay, Amy orders an ice cream cone with 3 different flavors. There are 26 possible flavors. How many different sets of 3 flavors can she choose? It's not asking how many ways she can arrange the flavors on her cone. It's asking what different sets she can choose. So that one is a combination. A teacher uses a random number generator to create a seating chart for 20 students. Does order matter in a seating chart? I think you guys would agree that yes, it does. Having Susie sitting next to Sally and David on the other side is not the same thing as Susie and David sitting together with Sally on the other side. So 4A is definitely a permutation. 10 athletes enter a race. The top 3 finishers move on to the next round. This one's a little tricky because we're thinking about the fact that there are people who are going to place first, second, and third. So there's an order there. However, the top three finishers move on to the next round. Does it matter if you got third place? As far as if you get to go to the top one, it doesn't matter if you're first, second, or third, all three of them get to go. So the order there doesn't matter. So 4B is a combination. All right, and that is it for today. See you guys later.